Welcome to qnawire.
Okay, so we're in chapter 29, problem 33. So we have a conducting rod that's resting on two long frictionless parallel rails and a magnetic field B, which we have pointing out of the page here. And if the rails are horizontal and the rod is given an initial push, will the rod travel at a constant speed even though a magnetic field is present? So that's what part A asks. So as the rod moves through the magnetic field, an EMF will be built up across the rod, but no current can flow. So without the current, there is no force to oppose the motion of the rod. So yes, the rod travels at a constant speed. So I'm going to write yes. Constant speed. Okay, cool. Part B now says, suppose at time t equals 0, when the rod has a speed v naught, the two rails are connected electrically by a wire from points A to B. Okay, so assuming the rod has a resistance R and the rails have negligible resistance, we want to determine the speed of the rod as a function of time. Okay, so we can set the force on the moving rod as obtained in equation or example 29.8. You can look back at that if you're confused after this. Equal to the mass times the acceleration of the rod. This is the second law, so we have F equals ma. And then we know that this is acceleration is dv dt. And now we can set this equal to what the equation of the force is. And that we know is going to be negative b squared L squared v over r. And now what we can do is separate variables such that we have dv over v is equal to negative b squared L squared over mr dt. So now we can just integrate. So if we integrate both sides from v naught to v, from t naught, but that's given as 0, so we can just do 0 to t. Make sure that's d prime and keep our dummy variables separate here. And what we're left with here is ln of v over v naught is equal to negative b squared L squared t over mr. Okay, well now we can just solve this for what v is and see that v of t is given as v naught e to the negative b squared L squared over mr t. Cool. So now we have the velocity as a function of time.